Hello, this is a demonstration of hypothesis testing with Spearman rank correlation coefficient. I'm going to use AQA S3 January 2012 paper question 1 as example. So let's start. First thing we do is read the question. Film released in the USA between 1998 and 2008. Information is available on the body count X and on the box office total gross takings $Y million. The total shown shows information for 10 films selected at random which have body counts greater than 50. Okay, so here's a table on this. So this is going to be our test data, and in the X column here we've got our body count, and in the Y column we have our takings in dollars. Yeah. Okay, so let's read what else it's telling us. Box office total gross takings are given in $1 million adjusted to 2008 figures, so they are comparable. A, calculate the value of the Spearman rank correlation coefficient between X and Y. That's A, so that's pretty straightforward. B, carry out a hypothesis test at 10% significance level to determine whether the value you calculated in part A indicates a positive association between X and Y. And finally, interpret your conclusions in context. Okay, first thing then, calculate the value of the Spearman rank correlation coefficient. Keyword there is rank. That means the first thing we've got to do is rank all the data in both columns. So let's start off with the Y list because that's pretty straightforward. Because they were interested here in a positive association, I'm going to rank them both in the same order from high to low. So highest value taking is Titanic with 1, and then it's already been ordered, this column, hasn't it? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so that's pretty straightforward. Now let's find the highest body count, highest figure in the X column, and the first one of those is 836 in Return of the King, so that's number 1. What comes next? 572, that's Troy, so that's number 2. 558, 3, Samurai, Last Samurai. What's coming next? 2 Towers, 468, that's 4. Titanic, 307 is 5. Winter Soldiers, 305, 6. Comes next. Rambo, 271 at 7. And where are we going next? We're going Saving Private Ryan is 8, 255. 9 is going to be Gladiator at 77, and 10 is going to be Bad Boys. So we've now ranked the data. Our next thing is we're going to use the calculator to work out our correlation coefficient. Okay, and we can do this because we just need to put the rank data in and it will come out with the Spearman answer. So here we need to put in the data. So I'm just going to copy this data in. First column is going to be the X column, 5, 1, 4, 2, 8, 9, 3, 10, 7, and 6. So that's the first column. And we look at the second column. We're basically going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's all the data gone in. Now I want to do the calculation, so we're going to go to graph. Look at graph 1. There's our scatter diagram of this data. We're going to go in calc and working for an X correlation, straightforward correlation with X. So here we are. Here's our results. Now the figure we're interested in here is the R value. That's our correlation coefficient, and because we've used the ranked data, this is going to be the Spearman ranked correlation coefficient. So we're interested there in the 0.515. Okay, so RS equals 0.515. 0.515. There we are. So I think we've answered the first question. Calculate the value of the Spearman rank correlation coefficient. Answer RS equals 0.515. Now the next part is carry out a hypothesis test. Okay, so what's the first thing we do in a hypothesis test is we set out our hypotheses. So H0, our null hypothesis. If we're doing correlation testing, then we start from the basis that the sets of data are independent. So the correlation between them is 0. Okay, that allows us to do calculations because we know what a 0 is and we can move away from it. If they were correlated, we wouldn't know what to do, where to start. Okay, H1, our alternative hypothesis. This one very much depends on what the question's asking you. In this case, they asked us whether there was a positive association between X and Y. So our alternative hypothesis is that there's a positive association between X and Y. And that means, in fact, we're only interested in a positive correlation coefficient, so we're looking at a one-tail test. We'll come back to that later on because that'll be useful to us. Okay, next part. What's our test statistic going to be? That's the next thing we find. Well, in this sort of correlation testing, our test statistic is going to be our R value, and as we're doing Spearman here, it's going to be RS. Okay, that's always the case, and we can check that in a minute from the information we're about to look up. We also need a critical value. Well, if we go in the tables, in the formula book, we can find table 9 sets out in the following data. So we'll look down and see what we've got. So reading the wording, table 9 says it's the critical values of the Spearman rank correlation coefficient. Let's read the first sentence because that'll be helpful. Gives a bit more background. The table gives the critical values for different significance levels of the Spearman rank correlation coefficient RS for varying sample sizes. Okay, so again, it's indicated to us that our test statistic is going to be our RS value, and what we're looking up here is the critical value. Okay, so what information do we need to fill this table in? Well, we need to know what the significance level is. Well, the question gave us a significance level of 10%, and we worked out that we're only interested in the positive only. So we've got a one-tail test, haven't we? So all that 10% is going to be at one end. Okay, here we are. So that means looking into the table and looking at the first row, it's telling us for the one tail at 10%, we're looking at this first column. The other piece of information we need to know is the sample size. Well, we know we had 10 films here, so n equals 10, and that gives us the row, and with that column, we now know that the critical value equals 0.4424. Here we are. So now let's draw our test line. And in one of these correlation ones, it's worth us thinking about the full range of values of the correlation coefficient. So the lowest value is -1, and the highest value is +1. Yeah, so that's our range. And in the middle, we have a correlation coefficient of 0. Now, going back to our null hypothesis, that was our assumption that they are independent and therefore the correlation coefficient is 0. So that's going to be H0, it's going to be in the middle. Now, we know that we're only interested in the positive values, and we worked out our critical value. We looked that up, and it was critical value would be 0.4424. So we're not interested to the left-hand end, we're only interested to the positive side of this. So we now know that the more extreme area away from our H0 is from our 0.4424 right up to 1. So that's going to be our critical region. So that's where our H1 is in our critical region. Next thing we're going to do is draw in our test statistic, which we know is 0.0515. So there's our test statistic, 0.515, and that falls within the critical region. So test statistic is greater than critical value, you've got to write, and H0 is rejected because the test statistic is within our critical region. So we've reached a conclusion for our test. The only other thing we have to do is look at our context statement, and here, this final sentence here, interpret your conclusions, here is asking us to do exactly that. Now, when we've done this in the past, we always start from a fundamental. Here, context statement always starts with either there is significant evidence or there is not significant evidence. Here we know that we got an H0 rejected, so that there is significant evidence. Evidence that. Okay, there we are. Now, as with all of these questions, I'd recommend you go back to what they asked you and lift and shift some of the words from it. So what did they ask us here? They asked us to carry out a hypothesis test at 10% significance level to determine whether the value calculated in part A indicates a positive association between X and Y. So we should be able to use that wording about a positive association. So go on from, there is significant evidence that there is a positive association between the X value, which I would write out as body count for context, and the Y value, which is takings. Yeah, so there we are. We've just got 10 marks. That was pretty quick and simple to get 10 marks, wasn't it, for carrying out those two pieces of work. And finally, what I've got for us here is a very quick summary of the Spearman rank correlation coefficient testing, hypothesis testing, with the points. Probably the only difficult point is the writing our test line, and I'd suggest we always start with a high line, because we know we're going from -1 to +1. Then if we see it's a one-tailed test, we have to pick which end we're interested in and put all the value at that end. So there you are. That's a note for you to write down. I hope you found that useful, and thank you for watching.